Hi, Algebra 2 friends. We're going to be talking about sequences today, and the type of sequences we're going to discuss are geometric sequences in section 11.3. So geometric sequences come off like this. Let's say I start with the number 3, then I multiply 3 by 2. That gives me 6. But I'm going to continue multiplying by 2. So 3 times 2 is 6, and 6 times 2 is 12, and 12 times 2 is 24, and 24 times 2 is 48, and 48 times 2 is 96. And of course, I can keep going. This is a geometric sequence. So what is the notable difference? Instead of adding, we are multiplying each previous number by a common ratio. So here's an example of a geometric sequence, and indeed we just got the next definition defined, common ratio, the value that we use to get from one number in a geometric sequence to another number. Here's the cool thing, we're using the word ratio, and so if I take any two consecutive numbers, say 48 and 24, and I divide them with the how can I say it, the next term, the term after one, so the term after the other term at the top, you know what I'm trying to say, we get the common ratio, right? So even, 24 over 12. I don't want to say the bigger one because sometimes the one to the right isn't bigger. So that's what the common ratio is, and then geometric means will probably be similar to arithmetic means. If I were to start off with a geometric sequence, something like this, and I had, let's start off with 2, and let's multiply by a half, so the next one is 1, and then the next one is 1/2, and then don't tell you about the next two, but so the next one would be, I'm not going to tell you, and then this one is 1/16. Then the values here are considered the geometric means. So the geometric means are the values between two non-consecutive terms of a geometric sequence. All right, so what we're talking about here would be apparently 1/4 and 1/8 would be the geometric means of 1/2 and 1/16. So here in example 1, we are given that we're dealing with a geometric sequence and we need to find the missing term. So how do we do that? First of all, having that common ratio is mad important. So remember, we can just take two terms and find the common ratio by dividing the latter term by the former term. And so when I reduce this, I end up with 5/2. So 5/2 is my common ratio. And so that gives me all the power I need to go to the next value. So what I do is I take 125, I multiply it by 5/2, and what do I get? I get 312.5. And if you're like me, you probably didn't actually do the multiplication. I just looked at the answer choices and was like, oh, none of these are coming out. This value will not come out nice because I know I'm going to have an odd number divided by an even, which would rock a 0.5 at the end. But when we multiply it out, it does work. It's true. It's true. And a bit of information we want to keep along with that is, here's the generic way of getting to the nth term. So because we're constantly multiplying by the same ratio, it just depends on how many times we do it from the initial value. So if I have the initial value and I want to get to the a sub n value, all I need to do is multiply it by the common ratio n minus 1 times. And if you think about it, it makes a whole lot of sense. So hold on to this. We're going to be using this little fact in the next couple of problems. So here in example 2, we're going to find a particular term. We're given of a geometric sequence. We're given that the first starting value, a sub 1, is -3, and the common ratio is -2. So our formula told us if I want to find some a sub n, I'm going to have to take that initial term, multiply it by r to the power of n minus 1. In this case, since we're looking for the 8th term, we're looking for a sub 8, and that's going to be a sub 1, which is -3, to the r, which times r, which is -2, to the n minus 1, or 7th power, 8 minus 1 being 7. So to do that, not too bad, -3, we need to deal with the exponent first. I'm now thinking about it. 2 to the 60, no, 2 to the 6th power is 64. So 2 to the 7th power is 128. But this is a -128 because I'm multiplying an odd number of negative numbers. And therefore, when I multiply the final negative times negative, I'm going to get a positive. But a positive what, you ask? I don't know. 8 times 3 is 4. Carry your 2. 3, 6, 7, 8. And 384 is our final answer. So a sub 8 would be 384. We're going to write an equation for the nth term of this geometric sequence. So a couple things that we need to know. We remember the generic formula again. A sub n, that looks like an R. A sub n is equal to a sub 1 times r to the n minus 1 power. And so we're going to use the details here to write a generic equation for someone who says, yes, I want to find the nth term of that particular geometric sequence. So we need to find r, and it's the common ratio, so we take the ratio of 12 over 3, and we get 4. So I've got r, I've got a sub 1, and I think I'm ready. A sub 1 is 3 times r, which is 4 to the n minus 1 power, and I think we've done it. That is the equation of the nth term of this sequence. So here in example 4, we're going to be required to find the 10th term of the geometric sequence. So we're starting with, we're only given a sub 4, and we're asked for the 10th term. In my mind, I feel like we can do this slightly different than the textbook did, which basically if we're looking for the 10th term and we have the 4th term, we can treat the 4th term like the 1st term, and therefore the 10th term would be like the 7th term, 6th term, 6th term, and then go ahead. So that's what I would probably do, but let's go ahead and do it the way the textbook asks us to do it. So a sub 1 is equal to, we're going back to that formula again, the a sub n rather is equal to a sub 1 times n times r rather to the n minus 1 power. We remember that, we've used it a number of times. So now since we have a sub 4 is equal to a sub 1 times, which we don't know, times r, which is 3 to the n minus 1 power, which is 3, right? Because n minus 1 is 3, get it? And so instead of writing a sub 4, I should do 108 is equal to this. And now we see we have an equation where only a sub 1 is the variable, and it's pretty cool to solve those types of equations really simply. So when I divide both sides by 27, I'm going to get that 108 divided by 27 is 4. So a sub 1 is 4. So now I can use the same formula and say, well, I'm looking for a sub 10 is equal to a sub 1, which is 4, times r, which is 3 to the n minus 1 power, which is the 9th power, right? So I can do that. I'm going to use a calculator to get that value. So I get that a sub n is equal to 78,732 by using a calculator to calculate all of that. So I'm still interested in the method that I wanted to choose. So what if I just pretended, what if I pretended that a sub 1 was 108 and therefore we're just looking for a sub 7? Would we get the same answer? So we would say a sub 7, and I use the different colors to say, hey, we're dealing with a different kind of a numbering system here. A sub 7 would be equal to a sub 1, that's 108, times r, which is 3, to the n minus 1 power, and n minus 1 in this case would be 6 power. And I'm going to go grab my calculator, and I'm getting exactly the same thing. 78,732 is what we get for a sub 7 in our system, which we know to be a sub 10 in the other system. I don't know. It's whichever one you like. I kind of like that this was a one-stepper, but whatever. I like the way the text processed it, so we got to use the formula twice, but ideas. So our final example is going to be about the geometric means, and we remember that from our discussion a few minutes ago that the geometric means would be the values between two non-consecutive or successive values of a geometric mean, so of a geometric sequence. So find the three means between this guy. So I'm glad they told us, because if there weren't three, there could be two. So we need that number. That's important to get to 576. So we're starting here. We're going to end there. So we're going to consider the formula again, and we get a sub 1, and this would be, we're looking for a sub 2, a sub 3, a sub 4, and here we have a sub 5. And if we put this together looking at the formula, what would be so awesome is if we had the geometric ratio, then we can just go plop, plop, plop and figure out the other values, right? So what we are going to do is use that formula. So a sub n is equal to a sub 1 times r to the n minus 1 power. Let's fill in what we know according to what we have. So we've got a sub 5, which is 576, is equal to 2.25 times the common ratio, which we're not sure of, to the fourth power. Yeah, to the n minus 1 power, which is fourth. And so now, this isn't so bad, guys. We divide both sides by 2.25, and when we do so, this actually comes out to 256, which is equal to r to the fourth power. And we're pretty tough. We can solve such problems. We can take the fourth root of both sides, right? Raise it to the 1/4 power. Grab a calculator if you must. And then, or if you can see it, that's awesome too. This is 16 squared, 256 is 16 squared, and 16 is 4 squared, so this is really 4 times 4 times 4. So r is equal to 4, but we have to actually consider that this could have been a positive or a negative 4, so I'm going to rock a plus or minus right there. And so now we've got two things that could happen here. We could be multiplying by a positive 4 over and over again. Let's see how that looks. So it's a positive 4. I'm going to fill in the blanks with a 9, and then 9 times 4 is going to be 36, and then 36 times 4 is going to give me 144. But if it's a negative 4 that we were working with, then we would have a negative 9. But then that negative 9 would turn into a positive 36, then that 36 would turn into a negative 144, and then that would be a positive 576. So we actually have two sets of possibilities. All right, guys, that's it for me. Let me know if this is making sense. It's a different type of sequence. And probably we're going to talk about what happens if this is a series, if we're adding up these values, what clever and interesting formulas come about. So that'll be our next lesson. Listen, take it easy, and I look forward to talking to each of you soon. Bye-bye.